Welcome back, everyone, and today we're going to do some more fun stuff. Today we're going to explore something I just learned recently, thanks to Jacob, who posted a tutorial of something me and three other people asked for to kind of explain how he did a certain effect. And, and Jacob did an awesome job of showing some source code and examples of how those effects work. But everything he does is in 2D, so we're going to actually bring this into the 3D world. And there's some cool things I came up with to use his idea. So he created this great tutorial, and these are some of the amazing effects he does, and it's all using a trick of how to connect two dots in 3D space. The minimum of two dots, essentially. In some of these examples, you have multiple dots, but they're all rotating and they're all connected in some fashion. A lot of great examples, and I'm actually going to explore every single example and recreate them at some point. But I'm going to start off with some of the basic stuff, and really start off with just this one image that he created. This is one simple bare bones example of how this is implemented. So let's get to it. And in very sketchpunk fashion, I created a new mini library for 2D drawing. I basically just used Canvas 2D that exists in WebGL, not WebGL, in your browser in JavaScript, and it's just like WebGL. We just grab the canvas and we ask for the 2D context instead of the 3D context. So just 2D. And very simple object I put together just to get enough pieces of it so I can actually experiment with this in a 2D way, which is a lot easier than have to deal with a 3D. Very simple function. This will be on GitHub if you want. I added a bunch of things in there just for funs. Took the render loop from Fungi. I think it's pretty much unchanged. There's maybe small, tiny little bit changes here and there. But so this way you can do animations. And kind of pour it over a library, a Vec2 function, bare bones, just to play around with in a simple math function. Some of these I really didn't need, but I just threw it in here anyway. Because, hey, if I'm building a mini 2D library for experimentations, why not? Might need it in the future. So we're going to start with this simple effect, right? And let's see. I want to. Well, I didn't prepare, but so the idea. Let's do this. So I'm going to put the link to his article and to his Twitter. So definitely follow him because he has some great stuff. And I'll show you the link to his blog, so you can actually read the entire tutorial and look at all the code and all the examples. But like I said, I'm only going to focus on this one animation only, just for this video, because it's a good way, because I did something with it at the end. So it's something in 3D is kind of fun. So I got 3 different files, and we're going to start off with the first one. And this is the bare bones concept of what he illustrates. This is like step 1. There's 2 steps, really. The first step is determine at least 2 points that are moving, and they're moving at different rates, preferably, and you're going to connect to them. We're going to connect from point A to point B in some fashion. Right now, I have it set up in a linear kind of way. It goes from point A to point B. That's it. Very linear. His approach is to do a lerp and a delay. Let's try lerping between, but without any delay. So at this point, I'm going to draw this. I'm going to draw, and when we're lerping, we're basically going to treat it as a path, just like how it is. Like there's that line path between the 2 dots that are rotating. Those are the main 2 points that are rotating. We want to connect those 2 dots, but we're going to go at a lifetime of this line to the same. We're going to add it to the rotation of this circle. So this circle already has a time, but we're also going to do a time for that line as well. So we're going to change that that path. The point in that circle is going to change based on that line. And T step is the steps we're taking. There's nothing up here. I have some constants, vec2s, and you know, I'm just creating time based on seconds. I'm using our render function, and I did every in his original code. He did everything as like individual like variables. I'm using vec2s to do the math, just to keep all the data together and neatly packed. And that's about it. So we're going to go from point A to point B, and we're going to lerp between the two. And like I said, as the further we get along, the faster we kind of spin around that circle. And with this kind of keeping it stationary, like I said, the time from here to here changes only on that position. And as you can see, it creates a pretty neat effect. We're kind of wavy. It's just how it lerps from point A to point B based on this one at a constant time, and this one also on a constant time, plus the time between point A to point B. If you get my drift, that's really the magic sauce. But then in his magic, his secret his secret spice is the delay. So that step that we kind of subtract time from, kind of like pushing away, we increase it based on a certain thing. So in this case, delay is set to 1, and I think this is basically, that's what we get. But if we set it to 2, things start to rotate a lot more, because we're now going back in time a lot faster. We're rotating a little bit faster. So we increase, so it ends up creating more curves. And the more delay you add to it, the more it starts to curve. Because as you're traversing the line between A and B, you're going faster and faster in the first row, and the first point. You're going faster. You don't visually see it, but when you create the points between the two with lerping, that's what's happening. You're just going faster and faster around the circle. So that point is at a different point, and the last thing really is that we're lerping between that point and this point. So we're transforming this constantly moving, this constantly accelerating dot. Like this dot is constantly accelerating. It's going the further down the line we go, it accelerates faster and faster. And we're going to lerp that current position to that position. And it's just a linear, and it becomes just a simple linear interpolation from A to B. And that's why we get those placements. So it's it's 2 moving points, a delay, and a lerp. And that is his magic's way to do it. Now, if I take the exact same code and then bring it into fungi, same ideas. I just had to create my own circle functions to create some circles. I'm using my debugger to kind of draw points in space. And the function is practically the same thing. It has it's almost the exact same code. Everything got transferred, except the only difference is these are now vec3s. And I'm putting in using the z and y instead of x and y. And this is how to create a circle for me. So if I want to take that 2D example, I can then make it into 3D. There you go. Now that is the same, like I said, it's the exact same code, just rewritten in a more 3D way. It's just in 3D coordinates. And you can just maximize the delay. It's hard to see, but maybe if I were to increase the steps, which is basically how many dots to make, be able to see the line a lot better. So you can see that the more the delay, the more loops you kind of see, the faster you're going in that circle, basically. like I was saying before, is like the further away is the slower we're actually increasing the speed. Yes, because we're increasing the speed. Hope I'm explaining that correctly. So that is his example in 3D. Now there's one more, and this is what I did. Now this is cool and all. This is great. Trust me, this stuff is awesome. Like but the way he uses it is to create these beautiful effects. But you don't have to create lines. These can actually be used as paths of movement. Like if you're dealing with particles and things like that, you can use these as actual movements for particles, like how this one does a lot of movements. So in the last example, let me see if I get the code out. Do I have it in 3D? My path one. Again, code is practically the same as the other 3D one. The only difference is now I have a new structure I call path, and I save the time. And basically, I'm trying to set it up so I can have path between A and B, calculate a random point in those two circles. So in the next one I'm going to show you, I'm going to pick a random spot on these two circles, and then kind of create a point that then traverses that path. Instead of drawing a dot along the path, I'm going to have a single dot traverse that path to go from point A to point B. And when it reaches the other side, it will explode. And like I said, that's I just do an update and do a lerp, copy the position to the point that we're rendering. Every time t becomes less than 0, we pick a new random spot. We calculate the starting and end positions, and and then move the points onto the circle, so this way you can see where it starts and where it ends. And we do the update. So in the update does the math. We're just going to increment time, which was step time before, but now I'm just traversing through basically by step, but my step is going to be in a constant increment. It's not going to it's like I said, the same thing. It's a starting point, but now it's not moving. I'm not moving T1 anymore. T1 stays the same. It freezes, like it's no longer continuously running. So it freezes, and that delay just creates that little curvature from start to end here. And at this point, I'm just going to animate kind of like just not a ricochet, just like an effect that makes it look like something blew up. A very simple. This is kind of when I was doing the shield effect, it's that shield impact effect, but I made it into like a 2D plane instead of a sphere. Different code, same effect. So if I go to the fun one, pow, and there you go. Poof. So it starts at that random spot, and it goes toward that spot, and when it gets there, it explodes. Or it shows you that there's some kind of impact happening there. And ta-da. Now that's why I said that's kind of really interesting, how he does it, is because you can those cool effects have a lot of motion. You can use these tricks to create paths for particles. And this can be a rocket, a heat-seeking rocket that's going out of control, but it managed to hit the point. It spirals, or you can do like magic fireball. A fireball kind of spins out of control and then hits your target. So so that's another cool use you can do, is just regular paths. So you're not constantly animating. You just pick 2 points, and then you traverse using those equations to create. And by changing the delay, you can change the paths. Trying to think. I guess if you really wanted to, delay is a constant. But if I say var, why not? Oops. Var. sometimes when I go off, things go bad. Let's see what happens if I random times 10 plus 1. Just in case it's a 0, I want to plus 2. Just in case it's a 0, I want to have at least a delay of 2. So every time we do an impact, we're going to change the delay, and that is going to change our path. So yeah, you can create, like let's say, a magic spell that every time you cast it, it just randomly flies in a different path. And that one was a little bit crazy, and but like I say, if you go through this tutorial and play around with a lot of the code and really just take it all apart and understand everything, because I haven't done it yet. Like I said, I only focused on that one image. But like think about it, just that one image, I came up with an idea of doing this, and in 3D no less. So yeah, there you go. Curved paths. All thanks to Jacob. Please go to Twitter and say thank you to him, because he did this. Is really awesome. I really appreciate it, and you know, follow him, and I don't know if he has a Patreon, give him $1 or something. I don't know. Like I said, I love that. That's a really great tutorial, and I told him I love it. It's awesome, and I said I was going to do something 3D with it, and I kept my word. Yeah, so I hope you guys learned something great. Like I said, he deserves it, because this is awesome, and this is going to be added to my repertoire of 3D effects as I learn and become a graphics programmer in the future. So please like and subscribe, and I'll see you guys in the next video.